A group of researchers conducted a study into the number of siblings of adult Australian citizens. They surveyed a total of 200 participants and recorded the number of siblings of each participant. A few days later, the lead researcher discovered that the survey data had been misplaced. Fortunately, one of the research assistants had been doing some rough calculations on a whiteboard, and the lead researcher was able to recover the following information, the information in this table, about the probability distribution for X and the mean mu. The letters A and B have been used to denote unknown probabilities. Write two independent equations for A and B. Well, the first thing is we know that the probabilities must add up to 1. So A plus B plus 0.3, which is the 0.2 and the 0.1 added, has to be equal to 1, which gives me that A plus B is 0.7. Let's call that 1. We know the mean is 1.3. Now, how do we get the mean? Well, we do 0 times 0.2 plus 1 times A plus 2 times B plus 3 times 0.1. And that would give me A plus 2B plus 0.3. And we know that's equal to 1.3. So that gives me that A plus 2B is 1. Just by subtracting 0.3 from both sides on this equation here. So if I do 2 take away 1, I get that B is equal to 0.3, and if B is equal to 0.3, then A is equal to 0.4. Later that day, the research assistant found the complete probability distribution in their records and discovered they had made an error in their original calculation of the mean. The correct distribution is now in this table here. Given that there were 200 participants in the study, complete the table below to show the number of participants with 0, 1, 2 and 3 siblings. Well, I could use my calculator for each of these, but if 0.2 gives me 40, that means that every 0.1 is 20. So this is going to be 60, this is going to be 80, and this one here is going to be 20, and that does equal 200. So it's a good idea to check. Determine the correct mean and standard deviation. So now that for the number of siblings this time, so we're going to have 0 times 40 plus 1 times 60 plus 2 times 80 plus 3 times 20 all over 200. So that is going to give me 60. Oh, I'm in the wrong thing. So let's go to main, and I'm going to have 60 add 160 add 60. Divide that by 200. The mean is 1.4, so that is the mean. And then to work out the standard deviation, of course we could just put this into the statistics package. In fact, that might be not a bad way to go. So let's just do that. Let's just go to the statistics package and think about doing that in here. So I'm just going to clear everything, and so our x's are 0, 1, 2 and 3, and put the probabilities in here. So 0.2, 0.3, 0.4 and 0.1. Actually, just thinking about that, we probably should put the frequencies in there, because otherwise we'll just get the mean for the distribution and we'll have to multiply it by 200. So put in 40, 60, 80 and 20, and then we can go to one variable stats. The frequencies are in list 2. Click OK, and there's my 1.4 that I just calculated. and then the sigma is the one that we use, so 0.917. So that's 0.917.